So we've taken this approach and broadened our view to the island-wide assessments. Megan has added some stable isotope values assessments across the islands, and you can see what the pattern that's emerging. The black arrows on this map indicate the 3 regions of injection wells on the island, and the redder or larger the circle, the higher the numerical value for that stable isotope in the algal tissue from those regions. So it seems quite likely that areas like Lahaina, as well as Kahekili, are potentially poised to have algal blooms driven by the injection wells leaking into those areas, but also cesspools and other kinds of fertilizers. It's not, the injection well is not the only place, but it may be the principal contributor. So this led us to possible identification of locations to start manipulating through the DAR's capability rules that would allow us to set aside areas where we suspect algal blooms are incipient or underway, but the fish numbers are not sufficient to crop those plants down. And using a thing that I've used for illustrating the relationship between grazing and herbivores, let me just give you a little bit of a primer on how we think coral reefs change. In the conditions where we have high grazer activity and low nutrients, we tend to expect corals as the principal cover in those areas. But as soon as we start shifting off from that balance of high grazing pressure and low nutrients, we could expect to see one of 3 other algal communities that are already present in those reefs become the dominant in those reefs. And so by what we have realized in areas like Kihei, the frondose algae are blooming without sufficient grazing activity because the nutrient levels are high. We can turn this around then and say, all right, if we have an area where there are a lot of algae, let's increase the grazing pressure and see if this is as a natural experiment as a way that we can manage the region. So on the right-hand panel are our field sites in the region of Lahaina. Here's a little bit more mapping the details for the injection plume. We've got stable isotope values in the upper corner for tissues from plants in these regions. One of the remarkable things is looking at bubbles that are being released from the benthic environment. This is not a typical feature of reef habitats. You can see a picture here of the algal blooms in the summer in the central panel, and that clearly dies back at least a bit in the winter. We've done some growth experiments with effluent from the Lahaina plant. And this slide gives you some of the details of those experiments. Here are some of the numerical values. I'd like to point out in this upper region, you can see that even 25 mils of effluent added to a liter of seawater can trigger rapid growth by algae. In this case, Hypnea. We also have data for ulva. If we look at these in terms of percent increase in weight over a period of time, we're seeing rapid growth increases with only 200 mils out of a liter. These are plants that are growing at that rate of doubling in about 2 days. So they're clearly able to use the nutrients in the effluent stream. This is the background then for understanding how setting aside an area to passively allow for the increase in herbivorous fish might allow us a means of controlling this algal biomass and bringing us to not just a single factor, but multiple factors in our management scheme. So from the DAR colleagues that I have, we have some slides showing the position of the sewage plant, which is here on the coastline, I believe less than a mile from the region. Coral studies are underway here. We have sites as controls. We've added characterizations of the benthic community. Notice in the northern end, if you can see it, there's more coral, the pink. And in the southern end, there's a little bit of more coral. In the central region here, we see increases, or I should say large amounts of algae as assessed by these benthic assessments. This corresponds with historical data sets where they've seen declines from about 50% coral to about 30% coral as an average for this Kahekili region. We've got fish information showing that parrotfish are generally high in the upper regions and the northern regions, but that central area tends to be low in the size of fish. and have started the characterization of these. From IVOR, we've obtained this broad basis of comparison for Kahekili Beach Park, looking at the seaweed cover and the fish biomass in contrast to other areas that are generally considered more healthy. I think we're on the right track. If we can close this area to herbivores, we can potentially expect to see a decline in macroalgal cover. This is the reef that we're looking at in terms of some of the better pictures of it. We've been able to use a number of interested parties, community scientists getting involved. We have employed Darla White to coordinate their activities as a way of gathering information as well, and support from this region. Further, we've got NOAA, which is over in the Kihei area, but their sanctuary program has allowed us to get them involved in growth studies that are using their fish pond and other areas. So with this, we expect to hopefully be able, within a relatively short period of time, see the land board give us permission to hold hearings that would set this area aside as a fisheries management area, specifically targeting herbivores in the area. If implemented, this rule will establish a marine managed area where the seaweed grazing fish will be the ones that will be protected from harvest, also including urchins. And the hope is that by passively manipulating the number of fish in this area, the number of grazers in this area, we'll be able to keep the palatable invasive algae under control. So this is our new approach, and I think that's all I have to say. Hopefully we'll have some data within the next 6 months. Thank you.